and welcome to class today. We're going to be talking about functions and relations today. A relation is any sort of pairing of an x and a y. Really, there are no rules with a relation. Everything that they ask you about, if they say, is this a relation? You'll just say, oh yeah, that's a relation. If it's any sort of x-y pairing, it is going to be a relation. Now, the first set of coordinates we're going to call the domain. Most of our cases, we'll call that the x. And the second set of coordinates we're going to call the range, and that's usually our y. All right, so here's our definition for function. Our definition says that for each element in our domain, it is paired with exactly one element in the range. So for each x, we have exactly one y. Now, each one of these that I have up here is a relation. So I'm just going to talk to you about whether or not it's a function because they're all relations. So what this means is that I will look at the x's or the inputs and make sure that there's only one x that's a 1, a 3, a 5, and a 7. So this one is a function because each of these x's is paired with exactly one y. I'm going to go here and look at each of these x's. A 2, a 3, a 1, a 0. That's a function. Each one is paired with exactly one y. So let's look here. A, B, C, D. That's a function. All of these have been functions. Let's look at this next one. A. Oh, you're not a function at all. That A is paired with all kinds of different numbers. Let's look at another couple examples. All right, so let's look at all these guys. I've got a 2, a 4, a 6, and an 8. You're a function. Let's look at the next one. 0, 1, 2, 1. Uh-oh. You see this one and this one? Not a function because that one is paired with two different y's. A, B, C, D. You're a function. A, B, C, D. You're a function. I don't care what the y's do, just as long as each x is paired with exactly one y. All right, let's look at a couple more and see if we can determine whether or not they're functions. Remember to just look at the x's, or the inputs. So I'm going to look right here and make sure that each one of these guys is paired with exactly one y. So yes, this is a function. Let's look at this next one. Oh, Chicago. You're not a function because that Chicago is going to two different outputs. So let's do a graph. Now, a really easy way to do the graphs to see if you have each x going to one y is to do something called a vertical line test. That makes it nice. So you draw a vertical line, and as long as it doesn't hit in more than one spot, just one spot or less, it's a function. So you're a function. Let's try you. Yep. Yes, you're a function. You're not a function. No. No. Yeah, you're a function. No, you fail miserably in being a function because you hit all along through here. All right, next thing we're going to talk about is domain and range. All right, let's look at what our domain and range would be. If you'll notice, the domain is the set of all the inputs. That's what's written right here. Oops, right here. And then right here is the range is the set of all the outputs. And we can write our answers in 1, 2, 3 different notations. Sometimes it's easier to write it in one than it is to write it in the other. And sometimes they ask for a particular notation and you just do what they say. So we're going to look here at example number 1. Let's write the domain. It's going to be easiest to do roster notation here. So I'm going to write A, B, C, D. It's the set of all the x's. Let's write the range. That would be 3, 4. Oops, I already have a 3. Don't double up. And then a 5. There we go. Domain. Let's see. This is going to be the roster again. Probably I'm not going to have enough room, so I'm going to write A, P, L, D, E, L, L, M, S, F, T, F, B, and G, R, P, N. comma. There should be commas in between. This one I'll write out a little better. It would be 562, comma, 12, comma, 29, comma, 32. Whoops, then C2, and then do my little curly Q bracket. Okay, that's my roster notation in that one. So let's look at our quadratic here. Domain is a set of all x's, so I just look left and right. And I see that these have arrows on the end, so that means it's going to keep on going up and up and up, and it's never going to stop. So the domain for this is negative infinity to positive infinity, and that's interval notation. So if I want to put it in set builder notation, I would have to write a set of all x such that we're going from negative infinity. Whoops, I don't know why I wrote that thing. Let me undo that sucker off there. Undo. X infinity. Another way would be to say the set of all reals, but this will work for us. The range, I'm looking up and down. Notice that the smallest y value I have is right here. It's at -4. So it goes from -4 on up to infinity for the range. Set builder notation would look like the set of all y such that y is greater than or equal to, because it can include on this one, -4. And that is an assortment of the kinds of problems that you'll have to do for this section. Now, if you have any trouble with these, be sure and email me and I'll be happy to help you. And y'all have a wonderful day. Bye now.